Okay, so this is KenQ analysis. It's the link from the session PowerPoint. And this is a really simple piece of software to use. I'm going to take you through an example. I've already got an example in here. One way in which you can do this is using a thing called user input. So you can put a name in. So I called it Changing Schools. That's the wrong way around, I've just noticed. And then what you can do is just paste in QSort statements. If you've got all of your statements, I've got them here, then you can put them in as a list. I put them in with the numbers. You don't need to, because whichever statement you put in first, it automatically gives it one. I didn't know this the first time I used it, so I'd put the one in as well. But you put all your statements in, and then you put your Q sorts in. So here's you say what the range is. So in my case, it was -4 to +4 for this example that I used in the other video. And then you sort of say how many values you have for each. And then when you're putting stuff in, you can either put statement numbers in there, or you can fill this in, and you can actually put numbers in each of these squares. And then once you finish, so I've inputted it all already. If I wanted to add a respondent to the data set, then all of this would become live. Then what it's doing is it's giving me all the values. So for statement 1, it's got a value of 1, for statement 2, -2, etc. So each of the 12 individuals who completed a Q sort, I put the statement numbers in these here. It knew what sort of shape to give it from how many statements were in each column. And then each time I finished one, I just sort of said, right, that's finished. I want to add a respondent, and it would just let me have another one. So that basically then means that that's all of the data that I've inputted. So if I go back to the PQ method file, which is a different way of doing this, as you can see, there you go. There's 12 people, 25 statements, changing schools between -4 and 4. And then there are 1, 2, 3, 4, 5, 4, 3, 2, 1 values. These are the values. This is just translating it across from what you've just seen. These are all the statements. And away we go. Okay. So the first thing that we do is create a correlation table. Sorry, my fault. Stage data for analysis. So there you go. Can you see I'd put one in that it's giving the values there. There's the data. And then the first thing I can do is create correlations. And all this is doing is sort of saying, look, if I look at here, this is the correlation data for respondent number 4 with 1, 2, 3, 4, 5, 6, 7, all the way through to 12. So this gives you an idea of how well correlated any two individuals are with one another. What it then does is it goes through factor extraction. So this is the point where it's trying to see how many factors there are. In other words, how many groups of similar people. Now, you can set how many factors you want to look for, how many you think you might be. So, I might sort of say, well, okay, I've got 12 people. Let's say there might be 4 factors, and that's just that it's doing it by, and I normally do what's called extract centroid factors. Okay, so if I do that, then what it's telling me is that when I look across this data, factor 1 has virtually no one, factor 2, factor 3, factor 1, factor 2, factor 3, factor 4. And then when I go down, hey presto, we said eigenvalue above 1. There's one very clear factor and one second factor. So we can probably go to 2 factors. Okay. So with the 2 factors, we then go to factor rotation. So how many factors to keep for rotation? Select, I'm going to have 2 factors because it's 2 factors above an eigenvalue of 1. That one just peeps in. Submit. Use judgment rotation or apply Varimax. I normally go for a thing called a Varimax rotation. It's an automatic way of doing it. Click on that. It's applied. Okay. And then as a result, respondent IDs, highest loading factor highlighted. Let's say you're going to do it in color. And what that then means is that when I look across here, factor 1.18, factor 2, 5.2. So all of the dark greens are factor 2. And again, if you see here, they're both high. That one is bigger than that one. That one is bigger than that one. For some reason, it's put it in here, but they're obviously quite similar. But all I'm going to do, therefore, is just click all of those. Okay. And then results, choose factors for output. So I'm going to look at factor 1 and factor 2, display preliminary output. And there you go. What it's saying is an idealized Q set for factor 1. So if you take those 8 people and sort of almost, if you like, average them out, what you get as an idealized Q sort, the sort of general Q sort, is this. And for factor 2 is that. Okay. And you then have a sort of a legend that sort of is talking about particular statements within that. So if you look up here, is that sort of closed circle and a thing. So that's distinguishing statement at p less than 0.01. So it's a statistically significant distinguishing statement. In other words, a lot of people feel that way. It's quite, important. And z-score for the statement is higher than in all of the other factors. Okay, so the Z statement, will come on to that in a minute, but what that's basically saying is that that particular statement there is very indicative of people's views. We can then look at correlations. So obviously factor 1 and factor 1 have a correlation of 1. They've got a lower correlation between the two of them. And then there's lots and lots of stuff here that we could look through. It's not so important, but where it does become interesting and the kind of things you want to spend more time are things like Z-scores. So a Z-score positive is when we look across the 8 people in factor 1, the if you like, the most common, really quite high value statement is change is a process full of opportunities. What this is showing is that these are generally positive statements for that factor. The most positive and the most generally positive statements up here, then goes down into the middle, and then at the bottom end, you've got things that people generally and most significantly disagreed about. And then you've got the same for factor 2. So if you remember back to the video, I looked at comparing the two and you could see where they were placed one relative to the other. And that basically is the if you like, the basic data set that you can get from this. It gives you an idea of which are significantly positive and negative, compare them. It gives you an idea of what an idealized version would look like, and you can display preliminary output. You can do other bits and pieces with this. This one I didn't. So let's have a look. You can normally get a few more details out of it, sort of a bit more data, but this certainly gives you more than enough to go on in terms of understanding what the data is showing you, and therefore it's quite an easy thing to do. It's not terribly difficult, sort of input wise. If we go back to the top, all you're doing is you're sort of saying, right, these are my statements in order 1 to 25, and then I've got this size, and if I've got a particular set of data, I can then just put the values wherever they were on that particular Q sort. Once I've completed it, hit add respondent to data set, fill it in again. So in this case, I had 12 of these to fill in. It took about 15 minutes, and it took about 10 minutes to just isolate all of the statements in the right order, drop them in from a text file, and then once all of those were there, I could then go to PQ method, and then just simply just go through it like that. And it is a really, really simple thing to do. And is really quite easy. You can even you don't even need to go back to the PQ method if you don't want. You can use the user input, go through there. It's all there. Create correlation table, factor extraction, extract principal components. You can play around in different ways with it. Centroid factors. There are my two eigenvalues. Got two. Verimax. Chosen those to show them, and then, as I say, that's all of my complete data. Okay, and same for factor 2. Job done. So you get some really interesting data out of doing this. It's pretty quick. It's certainly a quicker quantitative analysis than a lot of things. And KenQ is just so incredibly easy to use. If you also look on the web and put KenQ in, some different websites will actually have a simple guide on how to use it if you're not sure. So hopefully that gives you at least a taster of how to use KenQ analysis, and therefore actually be able to analyze your Q methodology data.